All right, so as you've noticed, trig substitutions are a huge pain. We want to avoid them at all costs. So it turns out I wouldn't have done any of the problems we've done so far with a trig substitution. I would have actually used a plain old u substitution. Turns out you get a little lucky on these problems. So we could have done all these problems by using plain old u substitution. So I'm going to let u equal my inside function there, which is x squared plus 1. So du dx is 2x. Solve for dx. I get du over 2x is equal to dx. So I'll go back to my integral. I got that x cubed there. I'm replacing x squared plus 1. I'm replacing that with u. Dx I am replacing with du over 2x. Do a little algebra. I can say, okay, I can cross off x's. So I got x squared over root u, and then I got du over 2. And now I got this problem. I'm mixing x's and u's. Can't mix x's and u's. I'm supposed to have everything with just u's in here. So you got to say, well, can I change this stuff with x in it? Can I change it so that it only has u's in it? Look up here. We want to get rid of x squared. Well, look at this. U equals x squared plus 1. Subtract 1 from both sides, and you get that u minus 1 is x squared. Aha! I can take this x squared here, and I can just replace it with u minus 1. All right. So why did I do this? Well, I'm going to think of that square root of u. I'm going to think of that as u to the 1/2 power. All right, that 1/2 there is annoying me. I'm going to pull that out of the integral. And then what I'm going to do is I'm going to split up this fraction. I'm going to say, okay, I'm going to think of that as u over u to the 1/2 minus 1 over u to the 1/2. I can do that. Normally go in reverse. Normally we take fractions with a common denominator and combine them into that. But here I'm going to do the opposite. I'm going to split it up. Use my properties of exponents. This is u to the 1 power here. So I'm dividing. I'll subtract the powers. 1 minus 1/2 is 1/2. So now I got 1/2 integral of, I got u to the 1/2. Then I've got 1 over u to the 1/2. I'm going to change that u to u to the negative 1/2. Well, now I'm just finding antiderivatives of powers of u. So, all right, so I'll go up a power to 3/2. Add 1 to the power. But if I do that, I better put a 2/3 in front. So when I bring down that 3/2, it'll cancel out. Here, all right, I better go on this guy. I better go up to u to the 1/2 power. But if I do that, I better put a power of 2 in front so that when I bring down that 1/2, it has something to cancel with if I take a derivative. Very last step of the problem, I just got to change my u's back to x squared plus 1's. All right. Let's see, x squared plus 1, the 1/2 plus c. So there we go. Got my answer. All right. So the moral of the story is this. Yes, trig substitutions. They can be used to get rid of annoying square roots. But they're a last resort. Trig substitutions are a huge pain. Look for other options first. In this case, in all these problems we've done so far, we could have actually done a sneaky u substitution instead, and it would have saved us some time and some heartache. So keep that in mind.